The IN2CARE station targets mosquitoes that are ready to lay their eggs. The odor lure attracts Aedes and Culex mosquitoes, which can transmit Zika, dengue, chikungunya, and West Nile virus. Attracted by the smelly water, the mosquito enters the station and searches a spot to settle near the water's surface. The gauze on the floater is an ideal location for the insect to land. She uses the gauze to rest while laying her eggs in the water. Unknowingly, she contaminates the water with particles from the gauze. These particles were transferred to her skin when making contact with her legs and body. The gauze has a special coating that uses polarity to bind mosquito-killing powders. The positive charge of the insect makes the particles transfer to her skin. Her body is contaminated with two different actives, one that slowly kills the mosquito and one that kills her larvae. After a few days, the eggs laid in the station hatch and become larvae. These larvae produce a smell that will attract more mosquitoes to lay eggs in the station, thereby enhancing its effectiveness. The larvicide in the water kills the larvae just before they are ready to pupate. The dead pupae sink to the bottom and are eaten by younger larvae. If the station contains many mosquito larvae, then this shows that it is working well. Fortunately, none of these larvae will ever become adult biting mosquitoes. They will all be killed by the larvicide. After laying a batch of eggs, the now contaminated mosquito flies out of the station. She goes and searches for another location to lay more eggs. Rainwater in an old tire provides a nice spot to breathe. When she contacts the water, the larvicide on her legs dissolves and contaminates the breeding site. This cycle is repeated when the mosquito continues to search other places to lay her eggs. At every stop, she contaminates the water with larvicide. Even the very small quantities that are transferred can effectively kill all larvae. In this way, she kills her own offspring, as well as offspring from other mosquitoes that use the same breeding site. With this technique, we control mosquito breeding in and around the station, even in sites that may be small and hard to find by pest control personnel. One station effectively covers an area of 400 square meters, which is 4,300 square feet. The larvicide is not the only bioactive in the station. The second agent is an insect-killing fungus. Its spores attach to the mosquito skin upon contact with the gauze. This fungus is a safe biological active that does not infect humans or pets. The spores use germination tubes to penetrate the insect skin. Once inside the mosquito, the fungus produces blastospores that excrete toxins. This infection makes the mosquito less active and reduces its ability to bite humans. It also inhibits the development of viruses in the mosquito gut. A fungus-infected mosquito can therefore still spread larvicide around the station, but cannot transmit disease. After a few days, the mosquito succumbs to the fungus infection and dies.